Hello and welcome back to this video. We are on episode 4 and this is the fourth stage, funnily enough. This is the final one. We're going to be looking at PowerShell, and from now on, well, for the next one we'll be looking at this executable, which is up here. Now this one is a lot more, maybe the best word for it is dense PowerShell. It's doing some pretty complicated stuff at a fairly low level. So rather than go into the weeds of exactly how every single line is working like word for word, what I'm going to do is abstract the broader ideas, explain what the script is trying to achieve, and look at it from that perspective, because otherwise it will take hours potentially, and there's a lot of pre-assumed knowledge that you'd have to have in order to really understand all of this. I've had to do a fair bit of research myself to get kind of even to a reasonable state of understanding it. So without further ado, let's first just explain what the comments are, because I did have a question about that. So these are essentially comments I've added. This isn't how it came from the malware author. I've essentially just mixture of my own kind of thoughts, feelings based on what I've read, looking at documentation, and also some liberal use of ChatGPT to fill in some blanks. Not every line is commented, but I've tried to get kind of fairly good coverage of what's going on. So first line is this byte array, creating a variable called image, and essentially it is using invoke web request to download this executable and then store it in this byte array called image. Then we have two functions, one called get delegate type and one called get proc address, GDT and GPA. If you're wondering what a delegate type is, I'll read out the definition. A delegate in PowerShell is a reference type that encapsulates a method, allowing methods to be passed as parameters and invoked dynamically. Which is a bit of a mouthful. Essentially what it's saying is, the purpose in this case is if we want to use something like virtual alloc, we need to pass the parameters which virtual alloc needs. One of those, for example, being the size of the space, which you want to create. Another one being like the page protections, I think is the best way to describe it. In fact, we can actually go up to here, which is a bit of a spoiler. And if you go to memory protection, so part of virtual alloc is this basically FL protect parameter, and this is essentially what protections you have. So if we go down to here, I believe it is, FL protect. These are the memory protections for the region of space to be allocated. So we need to pass these to virtual alloc if we want to use it to allocate memory. And in order to do that, this malware author is using this get delegate type. That's all we really need to know for the purposes of this analysis. Get proc address is essentially doing, it's getting the address of a process, or procedure actually. Sorry, not process, procedure. So you can see here, get proc address is called GPA, and it is here using this current domain get assemblies. So it is basically loading. The assemblies are what it's loading. It's looking at the assemblies that have been loaded into the execution context of the application domain, then returns a list of assemblies in this application domain. So basically all the assemblies which are part of the loaded application which has been passed to it. Again, lots of words. Details probably aren't too important to go into the nitty-gritty of all of that. But essentially, this malware author is using these two functions in order to work out where how it can call Win32 API functions, and then pass the appropriate parameters to them. So if you just go back to here, so virtual alloc it needs to load this in and then pass these parameters in order for it to run. The reason why it's doing this is it wants to execute this executable in memory rather than basically save it to the disk and then execute it from the disk. The reason why you do that is because it essentially is a really good way to bypass AV scanning. So it's doing quite a lot of work in order to load this into memory using the Win32 API virtual alloc, which is from, as we can see here, kernel 32. So it's from this kernel 32 DLL. So before I get to that point, I just want to head back to here. So this Marshall is basically a collection of methods for memory management within PowerShell. So essentially it can allocate memory using PowerShell. You might be wondering why, if it can do it with PowerShell, would it then use Marshall to load virtual alloc, which is a separate function for managing memory, when it can just do it through Marshall. From what I understand, this is essentially, it's doing it at a lower level using this kernel 32 virtual alloc, so it's less detectable. That might not be completely technically accurate, but that is, to the best of my knowledge, what it looks like it's doing here, based on my research. If anybody knows kind of the full details, I would love to hear. So next up we have this shellcode. Now, shellcode is essentially, it allows you to execute like raw assembly style kind of commands into memory, or traditionally into like a shell, like a command shell, bash shell, what have you. And this has, the limitations is obviously it can't be as big. You can't like load an entire executable, like a PE file worth of data in there. But what it's usually used for is like loading, or like in this case, I think what's happening is it is potentially unpacking data within this executable and then allowing it to run. So that's the shell's code, which is defined in this byte array here. And then we finally get to the meat and potatoes of what's happening. So VA address is get proc address of virtual alloc within kernel 32, and then VA del is get delegate type, and we're passing it here the parameters. So these are parameters it's expecting, and we can see these here if you go to Microsoft Learn. So it is a long pointer address, size, so this is the size of the like memory space we want to allocate, the type, and then the protection method. So if we just have a quick look at some of these parameters, if we have a look at the allocation type, we have memcommit, memreserve, memreset, and do. But you might notice that one we see is actually 3000 is the flag, not 1000, 2000, or 8000. But what we do see here is this or. So memcommit or memreserve. So that is in order to commit and to reserve and commit in one step. We can call it with this memcommit or memreserve. So what does that look like? Like, what does that mean? So this OR is a bitwise OR. So if we load up our favorite calculator app, which is here, which has already got the answer in here, but I'll just read it again for the sake of clarity. So if we take 1000, this is in hex, and then bitwise OR this with 2000, we get 3000. So that's what we need to know, and that's why in the PowerShell script here you see 3000 being passed to it down here. And then 0x40 is the final parameter being set to it, which is for set page execute read write. So that's basically page as in like memory page, and that allows it to be executed and read and written. So basically it can be executed the memory space you've just created, to put it bluntly. So that is virtual alloc. We then see create thread. So virtual alloc is allocating the memory, which you can see here for x. So x equals va invoke sc, so we can see that's the shellcode. Sc length, so that is the length of the shellcode. That's the amount of memory we want to allocate. 3000, which was the reserve commit, which we just described, and then 40 is the page execute read write. So once we've allocated memory, we need to create a thread for the memory to execute within. So like a process thread. So in order to do that, we are doing a very similar thing with get proc address, get delegate type. Here we've got a separate set of parameters we need to pass. So if we go to create thread, we can see here we have like thread attributes, stack size, start address, which is interesting. In a moment you'll see that, and then the along pointer to the parameter, which in this case is the actual executable that was downloaded, and the start address is actually the shellcode. So if we go back to here and we scroll down, we can see it's being passed to it. Where's it gone? Create thread. Have I lost it? Oh, I'm just blind, it's here. So we have create thread. So we see x as the third parameter, x being this virtual alloc like invoke of the shellcode. So if we just go back to here, the third one being start address, so the start address of the thread is essentially the shellcode. And then the pointer, didn't mean to close that. The pointer, the LP parameter, if you go there. So LP parameter is a pointer to the variable to be passed. So essentially a pointer to what we're passing, and this is image buffer, and image buffer is what we used to essentially load the executable itself. So if we go right back to the top, this exe, this is being loaded in not via virtual alloc, but via this Marshall class, which I described earlier, alloc h global, and this basically, you can read here, allocates a block of memory from unmanaged memory of the process. So allocating memory for this image buffer being the executable downloaded from that WordPress website, and then that is in the thread, the L pointer, so the long pointer to the parameter. There we go. Hopefully that makes sense. Let's just go back to here, and then finally we have this WFSO, which is wait for single object, which is probably best described as like a sleep. This sleep can be used to essentially wait for the thread to finish executing. So we don't want to the thread to close early because it's being created from this PowerShell process. We don't want it to, like, as soon as it's been loaded, for it to like finish execution, because it won't have time to, if it's being unpacked or whatever the shellcode's doing, to execute. So we're creating this, well, I say we, the malware author has created this wait for single object with a parameter passed to it as -1 being infinite. And you can see thread is the thread that was just created. And yeah, that's there. Hopefully that will make sense. It is, like I say, it's fairly dense in terms of its content. I could have talked for a very long time through this, but I just really wanted to, maybe not surface level is the best way to describe it, but kind of at least get some of the broader brushstroke concepts across in this video. So some use case ideas finally. This is obviously a lot more difficult to write use cases for, primarily because it's all happening in memory. Yara rules would be great for this, but I'd want to spend some time to do more analysis before suggesting what exactly Yara rules we want to do. This is obviously being used for a reason, and it makes it difficult to detect. But things like virtual allo can create a thread being run like from the context of PowerShell. It is like a parent process. Would be weird if you could create detection for that. That would definitely be something to, if that's possible within your environment, that'd be worth looking into. And then also like passing an address of a DLL to get delegate for function pointer. So this address of the DLL is obviously grabbed through get proc address. That would be very weird. I'm just, even some of these functions, like I would imagine things like get delegate for function pointer probably isn't used very often. Similarly, like Microsoft Win32 and safe native methods, maybe you wouldn't see that too much in legitimate PowerShell. Again, this is speculation based off just what PowerShell I've seen in the past, but there's probably a lot of more content in here that you could create detection content from, but this is coming to the point where it's not so easy just to kind of read it and say that would work, because you'd really want to do testing. So run this, and we'll probably do that in a future video, is defang it essentially. So what we could do is spin up a local server and then put up on a calc.exe, for example, and then see if we could execute this. First of all, would it even allow execution? I presume this shellcode would have to write our own shellcode as well, because if this is doing anything that's specific to this executable, and we put a different executable in, it would no longer work. But it's definitely worth playing around with, and this is kind of fantastic opportunity to test what would be detected, write some detection content, run the malware again, obviously using the defang samples. Unless you want to run it in a sandbox, you could do that as well, but then you're kind of having to potentially clean up every time from snapshot. And if we're not particularly, we're not at this stage, we don't really care what's happening here. We're looking at detecting this content here, apart from the shellcode and this payload. So just for the purpose of detecting everything else, it doesn't really matter if it's the actual payload and the actual shellcode or not. We could detect this activity, which I would pretty much be certain you wouldn't see in a benign context. So that is definitely an option. Hopefully this was useful. I apologise if it wasn't too well explained. This is definitely more complicated side of things than just kind of easy PowerShell obfuscation and explaining how things are getting downloaded and things like scheduled tasks or registry keys being created or removed. But it is definitely interesting, and if you have any feedback, please let me know. Thank you very much, and goodbye.